Good morning, welcome to Structure Companion. Our today's topic is support. At the end of this session, we should be able to say what are the types of support, to do the identification, and to tell why they are so important. So these are the three things we'll be learning today. So let's get started. We'll be studying the support in this structure. This is a bridge, and on this bridge you can see the support. What is the meaning of support? Support is a structure component that supports the load and transfer it to the foundation. That is a simple way of defining support. So this is a bridge. As you can identify, the dimensions are given. On top of this bridge, this is the place where the cars are moving. Here the cars move in this direction. So here you see the bridge, the loads that are coming from the cars that are passing through this bridge here. It is transferred to this bridge deck. This is the bridge deck here, and this is another bridge. This is another deck of the bridge, and this is another one. So the load are transferred to this bridge deck, and then from this deck it is transferred to this component here and this component here. So these are the support of the bridge, because the load is transferred to this structure, and then from this one it is transferred to the footing, and the footing is transferring it to the soil. So if you have to do a structure analysis of this bridge, you will not be drawing this bridge like this in the software or like in your hand calculation. You have to represent it in a very simple way. The very simple way of representing this bridge would be to identify this deck. So the deck, first of all, we identify what the deck. We have to represent this deck. Let's not talk about the deck. Let's talk about a beam. Okay, this is a beam, or okay, you can call it. Let's talk about the beam. Don't talk about the deck so much. Let's say this is a beam. Okay, and then from this beam, the load is transferred to the support here. Now, to identify it, this will be like this. Sorry. Okay, so we are going to draw. We are going to draw. Oops, sorry. Okay, we are going to draw the bridge deck. Okay, the beam. So this is the beam here, this one. So from this beam we have this support here and this support here. Look, notice that it is not continuous. The beam is starting here and finishing here. Another one starts from this one here and finishes here. So it means it is not continuous. It is not going all the way for the total length of the bridge. So the identification will be, you have this beam here, and then you have to identify the support. The support will be like this. Okay, this is one support. Okay, and then there is another one. There is another one here. So yeah. Okay, all right. So don't be so much focused about the size. The support are always represented with a small triangle like this. So from there, this support here is this one is a hinge support, and here we represent it as a roller support. All right, so here it is the hinged support, and here is the roller support. Okay, now in a hinged support, the particularity of a hinge support is what? The kind of reaction we have, like when we are designing the bridge, the kind of effort you need to determine or a vertical support, okay, a vertical reaction. The vertical reaction comes from all the loads that are applied on the bridge vertically like this. Okay, I'll draw it here vertically like this. So as the load are applied like this, that the load are coming from the cars and all the trucks and all this thing. So you need to determine this reaction based on the load which are applied. Okay, I'll call this load W. Okay, now in the hinge there is also another reaction which is a horizontal reaction like this that you need to determine. Okay, it is a horizontal reaction. Why there is a horizontal reaction? Because here the hinge supports cannot roll, like it is fixed here, it cannot move in the horizontal direction, and there is a vertical reaction because there is no sinking, like it's not sinking, it's not moving, so it has to support in the vertical way and in the horizontal way. So it means there's no movement at all, neither in the horizontal direction nor in the vertical direction. All right, now for the roller support here, what we have only a vertical reaction. So when we'll be calculating only identifying the vertical reaction. This is the roller support, only the vertical reaction. It is called roller because it can move. It can move in the horizontal direction. All right. So as it can move in the horizontal direction, it is called a roller support. So there is no horizontal reaction to calculate because all the forces when they are coming, they are directly dissipated. Like it is not, there is no restraint. It is going, it can go all the way. So there is nothing that can like stop the movement. If it would be like in the case of an hinge support, there's no movement. That's why you have to determine the horizontal reaction. So like if there is some horizontal load applied, like there can be an horizontal load applied on the bridge, okay, in this direction. This horizontal load can be maybe like, for example, for the brake load, like when you brake, when the car is moving faster and it brakes, this load can be estimated and applied on the bridge as an horizontal load, and you have to determine how much it is so that you can design correctly your support here. Now, in an actual structure, okay, in an actual structure, if you notice here as there is no movement in the horizontal direction, this support here is designed so that you cannot have in horizontal direction. It means there are some apparatus here that are correctly designed and properly calculated so that there's no movement at all in this direction. But here, as you can notice, like here you can see it is like a roller here. So here the kind of material used, the kind of apparatus used under this beam here allows the horizontal movement here. It allows the horizontal movement of the bridge in the horizontal direction. All right, so this is the way to identify it, because here you can have a horizontal movement. That's why identify it as a roller support. If you come to the next part of the bridge, you can notice that here it is blocked, like it can't move in the horizontal direction, but here there is a roller support. It means it can move. As you can see, it is a roller support, it can move. So here also as well, same thing, it can move. Here it can move in the horizontal direction, but here it cannot move. So everything is properly designed so that there is no movement. Like here there's no movement, here there's movement. So all the kind of material we will use and all the apparatus, the bearing system will be designed so that it allows a movement here and doesn't allow a movement here. It is so important to be careful and identify it as you did the calculation. All right, now why this is the first kind of support. Okay, this we said we have hinge support, you have roller support, you have also fixed support that I will be telling about later in this session, but let's focus on why they are so important. Like for example here, when you calculate a reaction, let's say for example you have a reaction here of 50 kilonewtons. Okay, sorry. Okay, let's say you have a reaction of 50 kilonewtons here. All right, so this 50 kilonewtons you have calculated based on the load. 50 kilonewton, it's coming from the load. Okay, I'll teach you, I'll show you how to calculate the reaction later. But let's say you did a calculation and you get 50 kilonewtons as the reaction here. Okay, so what does it mean? It means those 50 kilonewton will be supported by this structure here, this column. Okay, it will be supported by this column here. All right, those 50 kilonewton will be supported by this column. It means your column should be well designed so that it can carry those 50 kilonewtons. Let's say you did a calculation and you didn't calculate correctly. Instead of 50 kilonewton, you got maybe like, let's say 20 kilonewtons. Okay, 20 kilonewtons. What does it mean? If you get 20 kilonewtons and you design this for 20 kilonewtons, when the cars will be moving on top of this bridge, you have a problem with this column because you didn't design it correctly to provide for those 50 kilonewtons needed for the movement of the cars on the top. All right. Okay. So let's move to the fixed support. Okay, so here we have fixed support. What does it mean, fixed support? Fixed support meaning you have a structure. Okay, sorry, once again. It means you have a structure like this, all right, that doesn't allow any rotation of the bottom. All right, it can be like this, let's say like this. Okay, it means here there's no rotation at all. It is so fixed here. Let's say it is 90 degrees. After applying the load here, a load, let's say called P, the 90 degrees before applying the load and after applying the load, it remains the same here. It means even though after applying the load, let's say it is a column, okay, it is a column and this is a footing. Your column, after bending, to bend probably like this, let's say, okay, after bending, here it remains 90 degrees. There's no rotation. So this is called fixed support. Fixed support. All right. Fixed support means no rotation. No rotation. Before and after applying the load, the same, like it was 90 degrees, it remain 90 degrees. So there's no rotation at all here. So the kind of reaction you need to determine for this kind of structure is you have here a vertical load. That means you have to determine a vertical reaction like this. Okay, it is a vertical reaction. You have to determine a horizontal reaction as well, like this. Okay, after this one, and then you need to determine also a moment. There is a moment also which is generated. This is the way we determine a moment. This is the way we represent a moment. All right, so this is horizontal reaction, a vertical reaction, and a moment. Why we have a moment? This moment here is generated so that there is no rotation over here. All right, there is no rotation at all here. That's why there's a moment. This moment is there to restrain any rotation because we say it is fixed. So as it is fixed, there's no rotation, and then so that's for the no rotation to happen, we need to have a moment so that there's no rotation. What I forgot to say in the previous one, like for the kind of like if you have a is simply supported, let's say, sorry, 1 second. Let's say you have a simply supported bridge, all right? You have a simply supported beam, okay? The beam is simply supported. This is all the support. This is a hinge support, okay? And after applying, let's say we have a load which is applied like this, okay? This is the loads that are applied on the on this beam. Now, after applying the load, what will happen is we have a deflection, okay? The deflection means this beam will deform like this, okay? It will deform like this, all right? It means there's a rotation here. Let's say this rotation is called theta, okay? There's theta 1, and this is another rotation which is called theta 2. So why we don't have any moment here? Because like as I said before, this is a hinge support, this is a roller support, all right? So here the only reaction you have is a vertical one and horizontal one. Here only a vertical reaction because it can move. So here there's no moment because there is a rotation which is allowed, all right? If there was no rotation allowed, we could have something like this. It is fixed support, okay? Let's say fixed and fixed here. No rotation applied. So the kind of reaction you would have to determine was a vertical one, a horizontal one, and a moment. I'll just do it like this, okay? A moment. So 3 reactions you need to determine for this support. Let's say this is support A, this is support B. You need to determine the vertical, horizontal, and moment for all of it. Okay? So where do we find fixed support? Fixed support mostly, like for like where we always find it, is for a footing. What is a footing? A footing is, as I explained here, the footing, as it is drawn here as well, the footing is a structural component that spread the applied load to the soil. Here we have a soil. This is the soil, okay? Here we have a soil, okay? So with this soil, the one you apply the load, it is spread to the soil, and this is your footing. This is, let's say, column. There's no rotation at all. This is where you find a fixed support. And okay, all right. Now we'll be discussing now why they are so important. Why why the identification of the supports are so important and why to calculate them are so important. Like if you do a mistake, how critical it can be. All right. Okay. So welcome to our third module of this session, and here we will be telling why it is so important to determine the support and why the calculation of it is maybe the most important thing in a structure calculation. When you are doing a structure, whatever how complicated it can be, like it may be a bridge, it can be a building, it can be a dam, it can be whatever it is. reaction are the first thing we calculate, and they are so important. Why they are so important? Let's say you have a bridge like this. This one is a bridge which is designed in a software. Okay, there's a software that allows you to design this bridge. Now, you're using, for example, you're using a new software and you don't know if the calculation you did was correct. Is it like, are you sure everything is working? What you can do is to calculate the reaction. You have to calculate reaction. Reaction, you know, like for example, you know, this is, it is, let's say, let's assume this one is a simply supported deck. So from this one, from this example, you can go use a small sheet of paper as just we did before. You calculate the reaction and calculations, and you can compare the calculation you did by hand and the reaction that is coming from your software. In that way, you can know if the calculation you did is correct or not. So that is why they are so important. It means like you can have a complicated you can be having a complicated software design of a structure, and the only way to determine if the calculation you did were correct is to do the end calculation of a reaction, because it is very simple. It is the simplest, one of the simplest way to do, the simplest things to calculate in structure analysis. So if you calculate it by hand, your hand calculation, and you compare the reaction you did with your software, then it is correct for you, and you can say, okay, if you are having things that are pretty similar or close to each other, the calculation you did are very close, then you can say, yeah, my software, the things I've done in my software is correct. If not, you have to find out why the end calculation of reaction you did and the one you are getting from the software are so different. So that is the way to do to that's one of the things why support reaction are so important. Another one is when you are doing the design. Let's say for example you need to design this beam here. Okay, there is a beam you need to design. I just do it here. You have a beam you need to sorry. Let's say you have a beam you need to design. All right. Let's say you have a beam you need to design, and for example, to design a beam, you need to determine the effort, like the forces that are inside the beam. All right, the forces that are inside the beam. Here you have your fixed. Here you have your roller support. Okay, and then we have applied load, UDL. Okay, let's say you have some load that is applied here. Now, to design this beam, you need to determine what are the forces that are inside. To design the beam, what does it mean? To design the beam, it means you need to determine how big would be the beam. Okay, just here, how big would be the beam. Okay, you need to determine like what is. Oh, I'm sorry. You need to determine what will be the length, like the depth. Like this is the section. Okay, this is the section of the rectangle. It is a rectangular beam here. Okay, this beam is a rectangular one, so you need to determine when you're doing a design. You need to determine how deep will be this beam. How deep will be this beam here. Okay, and the depth. You need to determine the breadth. Okay, of this beam, and like if it is a steel structure or a concrete structure. If it's a concrete structure, you need to determine what are the reinforcement like which is needed, the grade of concrete, and all these things. Everything will be determined based on the calculation we have done here. All right. So to determine all this information, you need to calculate the moment. Okay. You need to calculate the shear forces, torsion, and all these things. Okay. To determine like all the reinforcement, the concrete, the dead, the bread, everything. You need to determine all these elements, like all these forces. Those forces, I'll be discussing about them later. Those forces are very related to the reaction you calculated here. So if you did a very bad estimation or calculation of the reaction, it means that your determination of the moment, the shear force, and the torsion will also not be correct. So to determine moment, shear forces, and torsion, you need to know your reaction. That's why reaction is maybe the most important calculation in a structural engineering point of view. Thank you so much. I hope you liked the session, and please do subscribe to our channel. Let's meet to the next. Let's meet to the next session. Thank you, and see you soon. Bye bye.